Completed?
Yes.
Okay. Next method in this case was regeneration. In regeneration, what we do? We want to increase the temperature of feed water. Okay. How it is achieved? So you can see here, first steam is passed to turbine. Now it is expanded up to certain extent. Then Y amount of heat is extracted and it is passed to feed water heaters. Okay. And remaining steam, that is 1 minus Y, it is further expanded and then it is passed to condenser. Then this Y fraction of steam, it is passed to feed water heater. Again, we have here liquid water coming from the condenser. This liquid water is heated by heat transfer between this steam and this water. This heated water is passed to feed water pump 2, then it is passed to boiler. In this case, our objective is to increase the temperature of feed water to reduce stress on boiler. आता boilerला तुम्ही जर एकदम कमी टेम्परेचर पाणी पाठवलं तर त्याच्यावरचा लोड वाढेल because it has to increase its temperature from very low to very high. But in this case, if you supply water already at high temperatures, then the load on boiler will decrease. Okay. So this is a cycle. Again, if you want to draw, you can draw. Okay, this is a regenerative cycle. 1 to 2 is a expansion, sorry, compression in pump 1. 2 to 3 is a heat addition in feed water heater. Again, 3 to 4 is a compression in pump 2. 4 to 5 is heat addition in boiler. 5 to 6 is first expansion here in the turbine itself. Then Y fraction is extracted at 0.6 and it is passed to feed water. Again, remaining 1 minus Y fraction, it is supplied or it is expanded to point number 7. This remaining fraction is supplied to condenser. 7 to 1 is a heat loss in the condenser. Okay. What is the efficiency in this case? Efficiency formula is same. Net work divided by heat added. So net work will be net turbine work minus net pump work. Net pump work will be pump work, pump 1 plus pump 2. So that will be W net and Q in. Q in this case, it will be H5 minus H4. That is the heat added in the boiler. Okay. Then there are two types for the feed water. This is the open feed water in which steam and water is directly mixed. In closed feed water heater, the water passes through pipes. Steam passes on the pipes. There is heat transfer takes place. This steam is condensed. Condensated is taken at bottom. This water is passed or it is pumped through pump number 2. It is passed to this mixing chamber. Now here we have water coming through these tubes. Here we have water coming through this pump. These are again mixed together. And this heated or high temperature water is passed to boiler. So this is a closed feed water heater. Mostly in actual power plant, you will see combination of these. So there will be open feed water heaters also. There will be closed feed water heaters also. Okay. So upcoming Saturday or Monday, I am arranging a guest lecture of one of my friend who is working in such power plants in Vizag, Visakhapatnam. He is going to deliver you insights about the actual power plant, the working, etc., etc. Okay. Now this is out of syllabus. We'll see later. There is one more point is there related to cogeneration. We'll see at the end of the lecture. So today we'll solve some numericals. Right. Okay. So be ready with your CAD and notebook. The numericals on vapor power cycle are every year asked in GATE examination. They will give you directly enthalpy values and they will tell you to calculate the efficiency of the power plant. Okay, so that way in GATE or IES, these questions are every year asked in the thermodynamics. Okay, so first question is here, in a steam power cycle, the steam supplied is at 15 bar and dry saturated. The condenser pressure is 0.54 bar. calculate the Carnot and Rankine efficiencies of the cycle, neglect pump work. Okay. Now here they have given steam supply. Now where steam is supplied? Steam supply. Okay. Where steam is supplied? Where steam is generated? Where steam is generated? Boiler. Yes. So in boiler steam is generated, and where it is supplied? Turbine. Correct. So steam is supplied to turbine at 15 bar. And its condition is dry saturated. So dry saturated means what will the dryness factor? 1 or 0? It will be 1. It is dry saturated. Okay. So now you can draw the diagram in this case because they have given enough data. So I'll draw a TS diagram, temperature versus entropy. So this is again, what is this is called? Sorry. This is called, what this is called? This curve is called. So what is this curve called? Huh? So this is a saturation curve. Okay. The left part here it is liquid saturation. Right part here it is vapor saturation. Summit point, this point is called as what? Huh? So this is what called saturation curve, right? The left part is called liquid saturation. Right part is called vapor saturation, and this summit point, apex point is called critical point. Okay, so that much you know. Now they have given the condition of steam at turbine inlet is dry saturated. So somewhere on this dry saturation or vapor curve, the point will lie. From this, there will be expansion in the turbine, right? Isentropic expansion, entropy will constant. Then there will be condensation in condenser, right? Then there will be pump. Then there will be boiler. So in boiler, the heat addition will take place. So this way your power cycle will look like. So this will be point number 1. What is this? So here the eraser is not. Okay. So this is point number 1. This is point number 2. Okay. 2 to 3 heat addition in boiler. 3 to 4 is expansion in turbine. So in this case, this is boiler where heat is added, Q in, or you can, okay, I'll write it as Q in. This is a work done in turbine. Then heat is lost in the condenser, Q out, correct. And this is a pump work, WP. In this case, they have said neglect the pump work. So this will be equal to 0. Okay. So here P2, that is pressure at 0.2, or P3, this is equal to 15 bar, it is given. Then condenser pressure P1 equal to P4, that is 0.4 bar, it is given. Then they have told you to calculate the Carnot efficiency, that is reversible, and actual efficiency, that is NPH. Okay. Now what is the formula for Carnot cycle efficiency? 1 minus TL by TH, that is lower temperature divided by source temperature. So in this case, you can actually write it as a 1 minus T2 saturated divided by TH higher temperature, sorry, this is higher temperature T2 saturated, and lower temperature will be T4 saturated. Okay. Now here you have to calculate the saturation temperature at respective points. So at, what is the higher pressure? 15 bar. At 15 bar, what is the saturation temperature? T2 saturated. So go to the steam table, go to the 15 bar pressure table and tell me the value of desaturation. Or in your app, mobile app also you can go, you type 15 bar pressure, dryness fraction, you give anything, it will give you saturation temperature. So some people try on mobile, some people try on steam table, no problem. 1.3 degrees Celsius or degree Kelvin? Degree Celsius, correct. So those are in online mode, please check. So at 0.4 bar, what is saturation temperature? This will be T4 saturation. So go to the pressure table again, go for 0.4 bar. In 0.4 bar, you check the saturation temperature. What will the value? 75.89 degrees Celsius. Now directly you can calculate the Carnot efficiency. So Carnot efficiency, that is reversible, that will be equal to 1 minus low temperature is 75.89 divided by 198.3. So this way you will get the Carnot cycle efficiency. So that means if you operate a Carnot cycle for this case, for given temperature conditions, this efficiency will get how much? How much? So those are in online mode. Please reply. Pranali Gaikwad 0.60. How much? 0.61. 0.61. Okay. So what is the efficiency? 61.7%. So this is the maximum efficiency you can achieve. So obviously our Rankine efficiency will be somewhat less than this. Okay. Now how to calculate Rankine cycle efficiency? So again I will draw the TS diagram here for your understanding. This is again what is this is called? This is called as saturation curve. And in this case, directly they have given the condition at 0.3, that is dry saturated. So here it will be isentropic. Here it will be like this. So by default, always assume the 0.1 is liquid saturated. Always assume 0.1 is liquid saturated. So some assumptions you have to make. 0.1 is always liquid saturated. Again, it is pump. And then you will get point number 3 here. So this is point number 2. Point number 3 is given dry saturated. And point number 4 lies in the wet region. Now in this case, you have to calculate Rankine efficiency. So what is the formula for Rankine efficiency? Net work done. So W net divided by QE. In this case, W net will be equal to turbine work minus pump work. So in this case, pump work is 0. They have told you to neglect it. Now how to calculate turbine work? This will be equal to H3 minus H4. Enthalpy at the inlet minus enthalpy at the outlet. So can you calculate H3 from steam table? H3 can you calculate? So for H3, you have to go at what is the pressure here? 15 bar. And H3 will be what? HF, HG. H3 will be what? HF or HG? HG, yes, correct. So whatever enthalpy we get at saturated liquid condition, this is called as HF. Whatever enthalpy we get at vapor condition, dry saturated vapor condition, that is HG. The difference between these two, it is called as HFG. So that is what is given in your steam tables. Okay. So at 15 bar, H3 will be equal to Hg, which is equal to how much? 27. किती आले तुमची? Okay, 2789.9 unit. What is the unit? Kilojoule per kg, correct? Okay. Now next is calculation of H4. How to calculate H4? This is very tricky question. Because here, in order to calculate H4, what is the formula for H4? For wet region? What is the formula? So HF4 plus X into HFG4. So whenever you want to calculate enthalpy at wet region, you have to take enthalpy at liquid condition plus X times the HFG, that is latent heat. Now here HF4 you can calculate. How to calculate HF4? So at 0.4 bar, HF4 will be equal to what? H1 or H4? So HF4 means the enthalpy of liquid saturated. So this will be equal to how much? So go to the steam table, go to 0.4 bar and check for enthalpy of liquid saturated HF. Kilojoule per kg. Right? Now how to calculate X? How to calculate X? That is a very tricky question again. So please pay attention. This is a new to you. How to calculate X? For that, we have to take advantage of this isentropic process. In this isentropic process, entropy at point number 3 will be equal to entropy at point number 4. Okay, because this is an isentropic process, entropy will remain constant. Now, what is entropy S3? S3 is nothing but SF3, sorry, Hg3. That is enthalpy of dry saturated condition at point number 3. So calculate Hg3. So at 15 bar, so at 15 bar, calculate Hg3. What is Hg3? At 15 bar, go to the entropy table, check for Hg. At 15 bar, go to the entropy table and say search for Sg, entropy of dry saturated steam. So those are in online mode. I will explain you with the help of steam table. Okay. So okay. So what I'm saying here previously, to know the entropy at point number 3. Point number 3 lies on dry saturated curve. So you have to go for 0.4 pressure table. So 0.4 pressure table. So here you can see 0.4. Is it there? 0.4? Yes, so here it is 0.4. Okay, here it is 0.4. You have to go to the entropy tables and you have to search for Sg. Sg is how much here? 7.671, correct? 7.671. Those who are not understanding, they can ask, no problem. S3 point entropy at point 3 will be entropy of dry saturated steam at 15 bar. So here Sg3 is how much? 7.671 kilojoule per kg per kg. Okay. How to calculate now? Next. काय येते? Okay, let me check. At 0.4 bar, the Hg value is 7.671. Na? Go to the pressure table. Correct. So now S4 will be equal to S3 will be equal to 7.671. Now you know the entropy at point number 4. You know entropy at point number 4. What is the formula for entropy at point number 4? Entropy of wet steam, how we calculate? So you know SF4 plus X into SFG4. Correct? Calculate the entropy of wet steam. That will be entropy of liquid saturated plus dryness fraction into SFG value. Now at 0.4 bar, at 0.4 bar. Oh, sorry. This is wrong. Actually, we have to go for 15 bar. Yes, I'm wrong here. So we have to go for 15 bar. At 15 bar, you have to search for SG value. So Aditi is correct. 15 bar. Here it is 15 bar. Here entropy is how much? 6.411. Correct. Okay, 6.441 kilojoule per kg Kelvin. Okay. Now at 0.4 bar, SF4 will be what? How much? Go to the 0.44 bar. Sorry, 0.4 bar. So at 0.4 bar, SF value is 1.026. So somebody write down. At 0.4 bar, SF value is 1.026. SFG is 6.4645. SFG is 6.645. So somebody write it down. Now check here. SF4 will be equal to how much? How? 1 point. What was that? 1.026 kilojoule per kg Kelvin. SFG was 6.645 kilojoule per kg Kelvin. Now you put all the values in this equation. Okay. S4 is how much? 7.671 will be equal to 6.441. Okay, my mistake. Once again. So 6.441 will be equal to SF4 is 1.026 plus X into 6.645. Now from this equation, you calculate the X value. Calculate the X value. Zero point 0.81. Okay. So Sudhir, our friend is saying 0.81. So others also confirm. Zero 0.81. So what is the meaning of 0.81? 81% is the dryness fraction, correct? That means 81% of water is converted into steam, correct? No? Right? And remaining 19% is still water. So that is the physical meaning of dryness fraction. Now why we have calculated dryness fraction? Because we wanted to calculate H4. The H4 काढताना आपल्याकडे HF4 होतं, HFG होतं, फक्त dryness fraction नव्हतं. So for that we have calculated X value. Now go to this equation and calculate H4. How to calculate H4? H4 will be equal to HF4 is how much? 317.7 plus X is 0.81 into HFG, how much at 0.4 bar, how much is HFG? So at 0.4 bar, 317.7 is HF. HFG is 2319.2. So here HFG 2319.2 kilojoule per kg. So 0.18 into 2319.2. So from this calculate H4. Calculate H4. Once again, I will write this equation here. 317.7 plus 0.1 into 2319.2. So calculate this H4. Two. 2196. 2196. Point. 25 or 49. Now, if you are doing by calculator, then answer should be same. What is your answer? Check. 196.49. Check. You check. If you are doing by same calculator, then answer should be same. Or whether your charging is more, they are charging is less. Is that the question? Are you calculating? 49. 25, na? Okay. So kilojoule per kg. Now why we are calculating H4? Because we wanted to calculate turbine work. Now you can calculate turbine work. So the turbine work will be equal to again H3 minus H4. Here H3 how much we have calculated? This is H3 2789.9. 2789.9 minus 2196.25. So calculate turbine work. Kilojoule per kg. Now, what next is required for calculation of efficiency? W net we have calculated. Q in you have to calculate. How to calculate Q in? Okay. So see here, Q in will be equal to what? H3 minus H2. Okay. Now, how to calculate H2? Here H3 we know, but we don't know H2. So H2 will be equal to H1 plus pump work. H1 plus pump work. In this case, pump work they have told negligible, so it is 0. So H2 will be equal to H1. Sorry. So H1. So H1 calculate. So H1, how to calculate H1? H1 is nothing but what? Enthalpy of liquid saturated condition at 0.4 bar. So you have to go for 0.4 bar. So at 0.4 bar, HF1 is how much? 317. So previously we have calculated, right? 317.7 kilojoule per kg. So H1 is 317.7 kilojoule per kg. Okay. So once again, pay attention here. How to calculate H2? See, H2 is here. H2's formula is whatever enthalpy at point number 1 plus this much pump work. So this much pump work is required. In this case, they have told to neglect the pump work. So pump work is 0. So ultimately, H2 will be equal to H1. What is H1? H1 is enthalpy at 0.4 bar at liquid saturated condition. That is the enthalpy. So here H1 comes out to be 317.7. This is equal to H2. So now easily you can calculate Q in. This will be equal to H3. How much? We calculated na H3. 2789.9. 2789.9 minus H2, that is 317.7. Calculate this. 2472.2 kilojoule per kg. Now calculate the thermal efficiency. 593.65 divided by 2472.2. Calculate. Point 247, okay? 240. So efficiency is how much? 24%. Okay, this is a Rankine efficiency. There is a little bit correction in the Carnot efficiency. Here we have calculated. So these values are in degree Celsius. You have to convert into degree Kelvin before calculation of efficiency. So again, please calculate these values in degree Kelvin. So here T2 saturation will be equal to 198.3 plus 273. How much? 473 minus 2. So it will be 471.3 degree Kelvin. And T4 saturation will be equal to 75 plus 89 plus 273. 278 and 70. 248, right? So, sorry, 348.89 degree Kelvin. Now you calculate thermal efficiency or Carnot efficiency. This will be equal to 1 minus 348.89 divided by 471.3. So calculate efficiency now. 0.25, or we can say efficiency is 25%. Now you can check the efficiency. If we employ the Carnot efficiency, sorry, Carnot cycle, you will get 25% efficiency. In the same case, if you employ Rankine cycle, you will get efficiency of 24%. So we can say this cycle is somewhat ideal because it is just 1% less than the Carnot cycle. So once again, I will repeat the whole process so that you will get understood. Okay. So here they had given you the boiler pressure, that is 15 bar, and they have given you the condenser pressure, that is 0.4 bar. Okay. And we have to calculate the efficiency of the cycle, both efficiency, Carnot plus Rankine. Carnot efficiency is somewhat simple. Its formula is 1 minus TL, that is sink temperature divided by source temperature. Here sink temperature is nothing but this temperature, T1, T4. Source temperature is T2, T3. So at 15 bar, we have calculated the saturation temperature, that is 198.3 converted into Kelvin. At 0.4 bar, we calculate the saturation temperature, that is 75.89 converted into Kelvin. And we calculated the Carnot efficiency, that is 25%. That is simple. But calculation of Rankine efficiency is somewhat difficult because its formula is net work divided by Q in. In order to calculate a net work, you have to calculate turbine work minus pump work. And in order to calculate Q in, you have to take H3 minus H2. Calculation of turbine work is H3 minus H4, that is enthalpy at inlet of turbine minus enthalpy at outlet of turbine. Calculation of H3 somewhat simple because they have given you the condition of steam, that is dry saturated. So dry saturated means we have to take Hg at 15 bar. So that is simple. But for H4, we don't know the dryness factor because H4 formula is HF4 plus X into HFG4. Here we don't know what is dryness fraction. In order to calculate dryness fraction, we took help of a relation, that is, this is an isentropic process. So entropy at point 3 will be equal to entropy at point number 4. So S3 is nothing but entropy at 15 bar at dry saturated condition. So S3 will be equal to SG3, which is 6.441. This will be equal to S4. Now for S4 is entropy at point number 4. So this way, how to calculate entropy at point number 4? This lies in wet region. In order to calculate any property in wet region, we have to take first the property at liquid saturated condition plus X into its latent heat. So S4 will be equal to SF4 plus X into SFG4. Here at 0.4 bar, you know SF4, you know SFG4, and you know SF4, S4 value. So directly you can calculate the dryness fraction, that is 0.8. As we have calculated 0.81 dryness fraction, we will put back into this equation of H4. We will calculate H4. As we calculate H4, we will calculate the turbine work. Okay. This is the first part, calculation of turbine work. Next is Q in, that is the heat supplied, which is equal to S3 minus H2. H3 we already calculated. Calculation of H2 is H1 plus pump work. Pump work is assumed to be 0 in this case. They have told us to neglect it. So H1 will be equal to, now again, enthalpy at 0.1. 0.1 lies on liquid saturation condition. Okay, curve. So we have to go for 0.4 bar. We have to search the enthalpy at liquid saturated condition, that is HF. So H1 will be equal to HF1. We calculated H1, then we calculated Q in. By knowing Q in and W net, we calculated the thermal efficiency. So any doubt how we process in this case? We solve more numericals so that we will get clear understanding. Yes, we are adding now. We are for calculation of H2. We are taking H1 plus pump work. So here they have told us neglect pump work. So that was why I have neglected the pump work. Okay. I hope all have understood in the online video also. So those who are taken the 2 doses, they must attend the lectures in offline mode. It is compulsory from 2nd March, that is from today. Otherwise, their attendance will not be marked. Right. Now, next example I have taken from GATE, that is GATE 1998. So such questions are always asked in GATE examination. I think the table is not visible or what? Huh? Still I will increase. Now is it visible? Okay, second example. A Rankine cycle operates between pressures of 80 bar and 0.1 bar. The maximum cycle temperature is 600 degrees Celsius. If the steam turbine and condensate pump efficiencies are 0.98 and 0.8 respectively. Okay. Calculate the specific work and thermal efficiency. Relevant steam table extract is given below. So they have given the directly table from steam table: pressure, saturation temperature, specific volume, specific enthalpy, specific entropy. They also given you at 8 bar 600 degrees Celsius, the specific volume is given, the superheat is given, and the entropy is given. So please write that table, write down the example. So I will draw the TS diagram here. So in this case, it is a little bit difficult. We don't know the condition of steam. So still I will draw, and at the end we'll correct the diagram. Okay. Don't draw the table because already you have in steam table. Aditi, do the smart work always. You are not supposed to do hard work. Huh? Already that table may be there, or you can refer from example also. But if you are writing complete table. Now see, pay attention here. They have given you two pressure values. The 80 bar, that is the boiler pressure, and here the 0.1 bar, that is a condenser pressure. Again, they have given you turbine efficiency 0.9, pump efficiency as 0.8. They have given you the maximum cycle temperature is 600 degrees Celsius. Also, they have given you the properties at 600 degrees Celsius, 80 bar, 600 degrees Celsius. So for just check, what is the saturation temperature at 80 bar? What is the saturation temperature as at 80 bar? Huh? Ah, yes, it is given 295.1. It is already given. And given temperature of steam is 600 degrees Celsius. So whether say steam is subcooled, wet, or superheated. If the temperature of steam is greater than the saturation temperature, so the steam is superheated. Okay, always remember, if the temperature is below saturation temperature, then it is a plain liquid water. If the temperature is above saturation temperature, then it is a superheated steam. So we can say that at turbine inlet, that is maximum temperature is this point. Point number 1 is at superheated region. Okay, there are three regions. This is subcooled region, this is wet region, this is superheated region. Now from table I can say the condition of steam at the outlet of turbine, sorry, boiler, it is a superheated steam. So point 1 will be superheated region. Now I can draw other diagrams. So here I can draw point H2. Now here also I don't know whether the point number 2 will lie inside the wet region or outside the wet region or on the curve. That is also I don't know. So that we have to calculate. Again, it will be in condenser. So by default, we have to assume the outlet of condenser is liquid saturated. Then again, pump work. So this will be pump work. So this will be heat added in the boiler, and this will be superheating. So this way, this diagram will look like. Let us say this was our point number 1, 2, this is point number 3, this is point number 4. So here again you have to calculate specific work and thermal efficiency. So how to calculate thermal efficiency? W net divided by QE. W net will be turbine work minus pump work. Turbine work will be how much? H3 minus H4. Pump work will be what? H1 plus, sorry, not H1. Pump work will be specific volume at point number 1 into P2 minus P1. What will the QE? QE will be equal to H3 minus H2. Okay. Now we'll calculate all the available values from this case. Now in this case, directly they have given you H3 value, that is the enthalpy at point number 3, that is given as 3642. So this is given. H4 again you have to calculate, that way you will calculate the turbine. At for pump work, the specific volume at point number 1, that is at this pressure, 0.1 bar. It is given, so at 0.1 bar, the HF value is given, sorry, not V value is given, that is this much. This is also given. This into P2 minus P1. P2 is given, that is 80 bar minus 0.1 bar. So this also we can easily calculate. Q in H3 is already given. H2 we can calculate. How we can calculate H2? H2 will be equal to H1 plus pump work. Correct? So in all these, the difficult task is to calculate H4. Difficult task is to calculate H4 because we don't know the condition of H4. आपल्याला माहित नाही H4 पॉइंट इथंच आहे, काय इथं आहे, काय इथं आहे, कुठं आहे आपल्याला काहीच माहित नाही. ठीक आहे? So slowly we'll calculate. So first I'll go with turbine work. So turbine work is H3 minus H4. H3 is already given how much? 3642, right? Super it is given 3642. So just time being, go to the steam table. Okay. Go to the superheat tables. Go to 80 bar and 600 degrees Celsius. Just cross check the enthalpy values correct or not. So go to superheat table for enthalpy. In that, search for 80 bar. I will also go. So I have to go for superheat tables. So see here, this is a specific volume superheat table, specific enthalpy superheat table. Okay. In this case, I have to go for 80 bar. So see here, this is 80 bar. This is 80 bar. In that, search for 600 degrees Celsius. So 80 bar and 600 degrees Celsius. So enthalpy is 3639.5. Okay. Have you located 80 bar superheated steam at 600 degrees Celsius? Enthalpy is 3639.5. How much is given in this case? 3642. Okay. So even though in steam table the value is 3639, you take the given value, that is 3642 kilojoule per kg. Now calculation of H4, very difficult task. Calculation of H4. Now let us assume H4 is wet steam. As we calculate, we'll come to know whether it is wet steam or whether it is superheated steam or is it a dry saturated steam. So at point number 4, we have to calculate the enthalpy. How to calculate? So H4 will be equal to how, what? HF4 plus X into HFG4. Okay. Again at 0.1 bar. At 0.1 bar, calculate HF4. How much is it? At 0.1 bar, HF value is given, that is 191.9. 191.9 kilojoule per kg. HFG4, that is at 0.1 bar, HF value is given, HFG value is given, that is 2392.3. 2392.3 kilojoule per kg. But we don't know the dryness factor. We don't know the dryness factor. So how to calculate dryness factor? So we have to make use of the process that is isentropic. So here S3 entropy at point 3 will be equal to entropy at point number 4 because the process is isentropy. So calculate S3. S3 is entropy of superheated steam, that is already given here, that is 7.0206 kilojoule per kg Kelvin. So 7.0206 kilojoule per kg air. This will be equal to S4. How to calculate S4? What is the formula for S4? S4 will be equal to SF4 plus X into SFG4. Okay. So here you can check. Okay. What is the condition of steam? So check for condition of steam at point number 4. The point number 4 line entropy कितनी है? 7.026. Okay, sorry, 0206. What is the SG value at point number 4? That is at point 1, SG value is 2584. 25, not 2584. SG value is 8.1494. 8.1494. What is SF value? 0.6488. 0.6488. Now check whether the given value is greater than SG or less than SF4, or is it in between SG and S4. So here we can say that S4 value is definitely greater than SF4, but it is less than SG4. So that is meaning of it is a wet steam. It is a wet steam. So whatever I have given here, that is point number 4, which is lie inside, that is correct. At this point, we will come to know the condition of steam. If the entropy given is greater than SG value, it will be superheated steam. If entropy is less than SF, that will be liquid water. If entropy is in between SF and HG, that means it is a wet steam. So now you can calculate the dryness factor. S4 is how much? 7.0206 will be equal to, what is SF? 4.6488 plus X into, what is SFG? SFG is 7.5. Now calculate X dryness factor. Calculate the dryness factor. So online, people who are attending online, 0.84. Okay. Pranali Gaikwad has given the answer. Others also cross check 0.84. Is it the correct? Yes, Pranali, correct answer. 0.84. That is the dryness factor. याचा अर्थ काय? कोणी सांगू शकेल? 84% steam and 16% water. म्हणजे 100% water बदले 84% steam convert झालेली आहे. 16% water अजून बाकी आहे. Now why we calculated dryness factor? To calculate H4. Now calculate H4. So H4 will be equal to HF4. What is HF4? 191.9 plus 0.84 into HFG is how much? 2392.3. So calculate H4. Oh, sorry, this is correct. This is wrong. At 0.1 bar, HFG is how much? At 0.1 bar, HFG. Okay, this is correct. At 0.8, it is less. Okay, this is correct. So H4 calculate 2201 43 kilojoule per kg. Why we calculate H4? To calculate turbine work. So calculate turbine work. S3 minus H4. So here S3 is 3642 minus 2201.43. Calculate. One four 40.57. Others also check. Kilojoule per kg. This is a theoretical turbine work, but they have given you the turbine efficiency that is 0.9%. That means there are 10% losses in the turbine. That also we have to consider. So actual turbine work, WT actual will be equal to efficiency of turbine into turbine work. Efficiency of turbine is 0.9 into turbine work is how much? 1440.57. So calculate actual turbine work. How much? 1296.5 51 kilojoule per kg. So we calculated the actual turbine work. Next is calculation of pump work. Pump work will be equal to specific volume at point number 1 into P2 minus P1. Now calculate specific volume at point number 1. It is at 0.1 bar. You have to search for VF1. So what is VF1? At 0.1 bar, VF1 is given, that is 0.00101. 0.0010103. Right? So pump work is simple now. 0.0010103. P2 is how much? 80 bar minus 0.1 bar. Convert bar into Pascal. So 10 to power 5. Now calculate pump work. Meter cube per kg. This is in bar. How much? 8072.29. What will be the unit? How it will be kilojoule? See here, we have converted bar into Pascal. So this is in Pascal. Pascal is Newton per meter square. This is the unit is what? Meter cube per kg. Here meter cube Meter square will cancel. What is remaining is Newton meter per kg. Newton meter is work done. Newton meter is nothing but work done. That is in joule. So this will be joule per kg. So always focus on unit. So this is in joule per kg converted into kilojoule. So this will be 8.072 kilojoule per kg. Now calculate net work. Net work will be equal to turbine work minus pump work. Sorry. Again, you have to calculate here actual pump work. Actual pump work. So pump work, actual, what is the efficiency of pump? Huh? 0.8. So I write down the formula, efficiency of pump into W pump. So efficiency is given 0.8 into 8.072. Calculate actual pump work. Calculate actual pump work. How much? 6 kilojoule per kg. Now you calculate net work done. So this will be equal to turbine work actual minus pump work actual. So turbine work actual is how much? 1296.51 minus 6.4576. Calculate. One two nine 0.05. Are kasar hai? Correct. Okay. Kilojoule per kg. This net work is also called as specific work. So they have asked you specific work. Specific work is nothing but net work. This is also called as specific work. So this is a answer number 1. So whenever you will write in university examination, whenever you will get an answer, if they ask you for calculate 4 parameters, whenever you get an answer, just put a dash, write down answer number 1. Because we as an examiner, as teacher check करत असतात. एवढा वेळ नसतो ना डिटेल मध्ये चेक करायला. तुम्ही भले 3 तास घेतले असतील, टीचर तेवढे 3 तास देऊ शकत नाही. टीचरने 10 मिनिटात पेपर चेक करत असतो. त्या केस मध्ये तुम्ही आन्सर लिहिलं ते आपण आन्सर नंबर 1 लिहिलं, आन्सर नंबर 2 डायरेक्टली फास्ट मध्ये चेक करतात. ठीक आहे, ऑलवेज follow this practice. Now next is calculation of efficiency. Calculation of okay. Now calculate efficiency. How to calculate efficiency? W net divided by Q in. Q in is how much? Equal to H3 minus H4. H3 they have given, that is 3642. The काढले आपण already. नाही ना? Huh? Sorry, H2. Correct. H2. H3 was already calculated. How much they are given? 3642. 3642 minus H2. Now here we don't know H2, but we know the formula. H2 is equal to H1 plus pump work. H1, have we calculated H1? No. H1 is nothing but, see here, enthalpy of liquid saturated at 0.1 bar. So at 0.1 bar, enthalpy of liquid saturated is 191.9. So here it is 191.9 plus pump work is how much calculated? 6.4576. 6.4576. So calculate this H2. Zero point 198. अरे 0 point and परत point कसा असेल 0.35 kilojoule per kg. Now you can calculate Q in 3642 minus 198.35. Calculate Q in. Kilojoule per kg. Now you calculate thermal efficiency. W net is how much? 1290.05 divided by 3443.64. Calculate. ह्यात फक्त कधी काय घ्यायचं तुम्हाला कळलं पाहिजे. 0.1 जर लिक्विड सॅच्युरेटेड असेल तर तुम्ही HF घेतली पाहिजे, एवढं तुम्हाला समजलं पाहिजे. बाकी कॅल्क्युलेशन सिंपल आहे. जर पॉइंट वेपर सॅच्युरेशन वर असेल तर तुम्ही HG घ्यायचा आहे. जर HG पेक्षा जास्त पलीकडे असेल तर तुम्हाला सुपर हिटेडचे व्हॅल्यू घ्यायची. कधी काय घ्यायचं एवढं जर तुम्हाला पहिल्यांदा अंडरस्टँडिंग आले तर पुढचं कॅल्क्युलेशन सिंपल आहे. झिरो पॉइंट हा बस पुढं 46. So efficiency is how much? 37.46%. So again, I will repeat this example for you. In this example, they have given you the tables directly. The pressures were 80 bar and 0.1 bar, but they have given it is superheated, that is 600 degrees Celsius. Next, they have given pump and turbine efficiencies. So in this case, you have to calculate a specific work, that is net work and efficiency. So for calculation of efficiency, this is a formula W net divided by Q in. W net is turbine work minus pump work. Turbine work is H3 minus H4. Pump work is specific volume into P2 minus P1. Q in here we can calculate H3 minus H2, and H2 we can calculate H1 plus pump work. So these formulas first you have to write down. There is a university exam असली, GATE exam असली, IAS exam कुठली तरी असली. First you write down the तुम्हाला काय करायचं मेथोडॉलॉजी लिहून घ्यायची. प्रॉब्लेम मोठा असेल की आपल्याला असं असं करायचं, स्टेप बाय स्टेप असं असं करत जायचं. एकदा मेथोडॉलॉजी तुम्हाला क्लिअर झाली की अशी करायची मग एक एक व्हॅल्यू तुम्ही कॅल्क्युलेट करत जायचं. एक एक व्हॅल्यू म्हणजे काय, पहिल्यांदा H3 काढा. H3 त्यांनी ऑलरेडी दिलेला आहे, दॅट इज 3642. ओके. नेक्स्ट H4. H4 मध्ये कन्फ्युजन होतं की H4 आत आहे बाहेर आहे का कर्व आहे, कुठंच आपल्याला काहीच माहित नव्हतं. मी फक्त एक डायग्राम काढलेली. परत आपण चेक करत गेलो, आपल्याला H4 कळली. S4 आपण कम्पेअर केली, HG पेक्षा जास्त आहे का SF पेक्षा कमी आहे का या दोन्हीच्या मध्ये आहे. हे याच्या दोन्हीच्या मध्ये आहे, दॅट मीन्स इट इज अ वेट स्टीम. म्हणजे आपण जे अझम्पशन केलं 4 इथं लाय होते, दॅट इज करेक्ट. Then we calculate the dryness factor, then we calculate the H4 value, then we calculate the turbine work. The turbine work calculate the actual turbine work by multiplying by efficiency. Similarly, we calculate the pump work, actual pump work, and then W net. This is also called as specific work. Last was calculation of efficiency. In that we have to calculate Q in. Q in with the H2 कसं काढलं, H1 plus pump work. Then we calculated the Q in value. Finally, we calculated the efficiency. Okay. So we have two more examples, but today we'll take one, and one I will give you as homework. Okay, but I expect the next example you should solve it. So in a Rankine cycle, the steam at the inlet of turbine is saturated at pressure of 35 bar. Exhaust pressure, that is condenser pressure, is 0.2 bar. Determine pump work, turbine work, Rankine efficiency, condenser heat flow, dryness at the end of expansion, assume flow rate of 9.5 kilojoule per second. So please give it a try. Refer your previous examples. I will come within 5 minutes. Is similar, just follow the previous workflow. Again, in this case, you don't know the quality of steam at turbine outlet. So just assume it is a wet steam. Afterwards, we will get to know what is the quality of steam at outlet of turbine. So I will draw the TS diagram. Turbine versus, sorry, temperature versus entropy. This is a saturation curve. But here they have given the condition of steam at inlet to turbine is saturated. So this is a saturated condition, dry saturated condition. And then the remaining cycle will be easily drawn. So 1 to 2 to 3 to 4. Okay. Here it is 35 bar. Here it is 0.2 bar. So they have told you to calculate a lot of things. So let's focus on efficiency. Or we go one by one. So they first have asked pump work. How to calculate pump work? What is the formula? Specific volume at point number 1 into P2 minus P1. Specific volume at point 1 is nothing but VF1 at 0.2 bar. So calculate at 0.2 bar, go to steam table. Huh? 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 हाँ एक नहीं है girls check or I will also check with the help of steam table. So here I have to go to pressure tables, then I have to go for 0.2. So see here pressure tables at point number 2, VF value is 0.001017. Correct. So pump work, how much it will be? 0.001017 into P2 is how much? 35 bar minus P1 is how much? 0.2 bar into 10 to power 5. Calculate. हाँ 3539. हाँ हाँ हाँ. Please check those who are doing in online mode. Please check. Pranali Gaikwad, Dakshita Kareem, or others, those who are attending, please pay attention and give the values. So pump work is 3.539. Is it correct? Is it correct? 539. Okay. So so this is answer number 1. Let us go to second part, that is turbine work. Second is turbine work. So WT will be, turbine work will be what? H3 minus H4. H3 will be what? SG3 at 35 bar. Now go to steam table at 35 bar. Pressure table, go for Hg value. Tell me. Two eight. Point. मग कशाला 0 सांगतोय? पुढे काय आहे का? नाही का? 2802 kilojoule per kg. How to calculate H4? Again, same process we have to follow. H4 will be equal to HF4 plus HFG4. 4. X times HFG4. Here X is unknown. We don't know the value of X, that is dryness fraction. Again, you have to follow the same process, calculation of dryness fraction. So again, in this case, you can see entropy at point number 3 is entropy at point number 4. So S3 will be equal to S4. S3, how to calculate? This is nothing but SG3 at 35 bar. So at 35 bar, what is SG value? Six point kilojoule per kg per Kelvin. So we know S4 value now. Now S4 is also equal to, it is in the wet steam. Formula for wet steam is S4 is equal to SF4 plus X into SFG4. So now here SF4 at 0.2 bar is how much? So at 0.2 bar, what is SF? 0. Kilojoule per kg Kelvin. And what is SFG? 4 at 0.2 bar. What is SFG value? 7.077 kilojoule per kg per Kelvin. Others also please check if there is any. If you are getting another value, please let me know. Now you put this into this equation. So S4 is calculated equal to S3, that is 6.123 equal to 0.832 plus X is unknown into 7.077. Calculate X value. Calculate X value. Point 74. 7476. Why we calculate X value? Because we want to know H4 value. Now you can calculate H4 value. H4 is HF4 plus HFG4. Again, I will write down HF4 plus X times HFG4. So HF4 at 0.2 bar. How much? HF value at 0.2 bar. 0.5 kilojoule per kg. HFG value at 0.2 bar. 2358.4 kilojoule per kg. Calculate H4 as simple as it is. 251.5 plus dryness fraction is 0.7476 into 2358.4. Calculate H4. Two 014 639 kilojoule per kg. Now last is calculation of turbine work. So turbine work will be equal to H3 minus H4. So H3 is how much? H3 is how much? 2802. 2802 minus 2014.6 minus 2014.6. Calculate how much? 7 35 kilojoule per kg. Okay, turbine work calculated, pump work calculated. See here again, in this case they have given you the mass flow rate. Okay, now if you want to calculate this in kilowatt, you can calculate. So here pump work is how much? 3.539. So 3.539 into mass flow rate, that is 9.5. Calculate. This will be in kilowatt. This will be in kilowatt. Okay, why? This is in kilojoule per kg into mass flow rate is in kilojoule per second, kilogram per second. So kilogram will cancel. Kilojoule per second is nothing but kilowatt. Here also you can calculate 787.36 into 9.5. Calculate. Calculate. 7479.9 kilowatt. Okay. Next, they have told you to calculate the ranking efficiency. The ranking efficiency, that is NTH equal to W net divided by Q in. W net is how much? Turbine work minus pump work. So turbine work is how much? 7479.92 minus 33.62. So calculate this. 74.3 है ना, correct. Kilowatt. Q in H3 minus H2. H3 we already know. Calculation of H2 is H1 plus pump work. H1 is nothing but what? Is the enthalpy at dry saturated condition, which you already I think have calculated. So H1 is HF1 at 0.2 bar. I think we have already calculated that value. So H1 is nothing but HF4 also 251.5. Okay. Pump work we have calculated in kilojoule per kg. How much? 3.539. So this will be what? 8. Actually, mass 255.039 kilojoule per kg. This will be H2. So Q in will be equal to H3 is how much? 2802 minus 255.039. Calculate this. 2546 96 kilojoule per kg. Correct? Correct. So convert this into kilowatt to 2546.96 into 9.5. What will be in kilowatt? Kilowatt. Okay. or you can say 24 megawatt. So thermal efficiency will be equal to 7446.3 divided by 24,196.12. Calculate. Point 3077, or you can say efficiency is 30.77%. Now last two things are remaining here: condenser heat flow and dryness at the end of expansion. The condenser heat flow is nothing but Q out. Q out, how to calculate Q out? This is a Q out. H4 minus H1. So here Q out will be equal to enthalpy at inlet of condenser minus enthalpy at outlet of condenser. H4 have we calculated? Yes, H4 we have calculated 2014.639. 2014.639. H1 is how much? 251.5. Calculate this one. Huh? Point 139. Others check. Correct है क्या? Kilojoule per kg. So 1763.139 into 9.5. That will be in kilowatt. So calculate this also. 60. Kilowatt. So we have calculated all the answers. Here, first one is here itself, answer number 1. Then we have calculated turbine work. So this is answer number 2. Third is calculation of Q out. So this is again answer number 3. Fourth, they have asked the dryness at the end of expansion, that is X value. So X we have calculated as what? 0.7476. 0.7476. So this is again answer number 4. Okay. So any doubt up to this point? Any doubt? So simple process it is there. ठरलेले formula आहे, ठरलेली process आहे. You have to calculate. So take down this example for homework and we'll solve it next class. So write down this example as a homework and we'll see in next class. So initial condition of steam being dry saturated means at the inlet of turbine. So as in previous example, so write down for homework. We'll solve in next example, next lecture. So those who are in online mode, please enter your attendance in the chat box. Today is 2nd March. Roll numbers 13. तिकडे नाही तुमच्या आधी कोण किती 47 okay. So write down this example for homework and try to solve it. Same process you have to follow as we followed for the other examples. Okay, so with this we'll stop here. In the next lecture we'll take this example and MCQ questions related to this chapter, and in next lecture we'll start the next chapter or next section number 2. The chapter is steam nozzle and steam turbines. Okay, again that chapter is related to steam nozzle, steam turbines. After that, chapter number 5 is steam condensers, and chapter number 7 5 is condenser, 6 is reciprocating air compressor. So that way we'll go through this. So section 1 is, I can say, it's completed today, and in next lecture we'll start section number 2. So thank you.